All right, this is the lesson over section 2.4, measures of variation. All variation means is how data changes. Last time we talked about how, if we had a set of data, how things are in the middle of the data. Well, variation talks about how it changes across the data, or from one end to the other. How the lowest one differs from the highest one, or how they differ all the way through the set. So measures of variation. How to find, what we're going to learn, how to find the range, how to find variance and standard deviation. Those are the main things right there. This first class, that's all we're going to talk about. Then we'll talk about the empirical rule and Chebyshev's theorem and how to interpret standard deviation. And we'll also deal with coefficient of variation. We're going to talk about that. But this right here is what we're going to deal with. Oops. This is what we're going to deal with today. We're not going to talk about the empirical rule and all that in this lesson. First, range. Range is pretty easy. Data's got to be quantitative, so it's got to deal with numbers. And to do your range, you just take the maximum minus the minimum, highest minus lowest. Don't make range harder than it is. We don't use range a whole lot, but we will use it some. We don't use it a whole lot because it only uses two pieces of the data. And I'm not going to worry about finding the range here real quick. We will do this one real quick. But we look for the highest number through here, and it looks like the highest is 47. Looks like the lowest is 37. So we just subtract those two and our range is 10. That's all you do to find the range. Then you do need to go back, and I didn't read the whole problem, but you do need to go back and sort of see what that means to the data. So the range of the starting salaries were about $10,000. Could have a range or $10,000 one way or the other. Deviation, difference between the data entry. Data entries we're going to always term as X, and the mean. Remember, for mean, last time we talked about the mean. Could be X bar if you're dealing with the sample mean. It could be mu if you're dealing with the population mean. So you got to know the difference between those two. One, X bar is for sample, mu is for population. So here we talk about, for the population, you just do X minus mu. And what you're going to have is you're going to do a chart. You're going to list all your X's. Then you're going to do all your X's minus your mu or your X bar, depending on if you're dealing with a sample or a population. So we're going to make a chart, and we're just going to add columns to this chart. Corporation hired 10 graduates. They give us the 10 graduates here, and we're just going to go over this real quick, and thousands of dollars. First thing we want to do is we want to find the mean. So we add them all up. We get 415. Divide that by 10, and you get the mu, or the mean, is 41.5. So the mean salary of these graduates is about $41,500. Then once we have that, then what we do is we take each X, so 41, and we subtract whatever the mean is. So 41 minus 41.5, then 38 minus 41.5, then 39 minus 41.5. Notice that these are negatives in this case, and when we get to ones that are higher than the mean, then it's going to be a positive. And the sum of all of these should always sum up to be 0. Because all we're finding is how far each item in the set is from the mean. Well, when you total up all that, it should total up to 0 because everything should go towards that mean. the sum of all the deviations, this is what I was just saying, will always be 0. It doesn't make sense to find the average of those deviations because the average is always going to be just 0. So what we actually do, we treat them like distances on a number line, and what you're going to do with each one is you're going to square them. So if you had a -2, well, you square that, and it ends up being a +2, because we're talking about how far that number is from the mean, or that middle average. And this is called the sum of all the squares. Sum of all the squares. And that's another part of our chart. We just had that chart. This is going to be your x. Then you got x minus your mu, or your x bar, whichever. Then the next column you're going to have is that x minus mu and all that, each one squared. So you're going to find your x. Let's say it's 2, 3, 4. Then you're going to find how far this 2 is from the mean if we knew the mean. So x minus whatever the mean is, let's say it ends up being a -4 or something like that. And then you're going to take that -4 and you're going to square it. Well, -4 times -4 is 16. So we're going to make out this chart every time. Sigma. Just write this down. This is the sigma. It's a Greek letter, and sigma is what we're going to use for our variance and our standard deviation. We'll talk about that here in a second, but just so you know that that's a sigma. Population variance. So when you're finding the variance of the whole population, this is the formula you use. This right here, sigma squared. Anytime you see sigma squared, that's going to be variance. That stands for variance. N stands for the total numbers in the set. All right, so just how many numbers there are in the set. And this top part, that's the sum of the squares. That's the sum of all those squares that we had if we were doing this list here. And you got x, x minus mu, and then you got x minus mu squared. Well, when we get down here to the bottom, we want to sum up this whole column, and that's what goes on top there. Population standard deviation. This looks like a big, long, hard formula, but once you have all this stuff done that you did for population variance up here, all you got to do is take the square root. So you're going to take this answer that you got from up here, and then you're going to take the square root of it, whatever it was. So you go to this column, add all those up. That gives you the answer that goes on top. You divide that by how many numbers there were in the set. That's going to give you the standard deviation, the sigma squared. Or I'm sorry, that's going to give you the variance, the sigma squared. And then once you have the sigma squared, the variance, then you just take the square root of that, and that's going to give you just sigma, which is your standard deviation. Now this is all for if you're doing a population set, and there's going to be other formulas for doing a sample set. All right, so to do this, I'm going to put these steps up here. There's 6 steps to finding the population variance and standard deviation. First thing you do is you find the mean. So you add them all up, and you divide by how many's in the set, which is n. And that's what this formula right here tells you. Mu stands for your mean, summation x there, so you add up all the x's. Then you divide by how many numbers there are in the set. To find the deviation, step 2, find the deviation of each one. You just take each x and subtract off your mean. Then you take each of those answers and you square each one of them. And that's going to turn them all into positives so that we can deal with them, because otherwise they would all add up to 0. Next thing you do to get the sum of the squares, you just take all the answers you got from this step and you add them all together. You sum them all up. That's what that Greek letter there means. Sum them all up. Next two steps. Once you have that sum, you put it on top here. Put how many numbers there were in the set on bottom. Grab your calculator, you divide that. That's going to give you your sigma squared, which is your population variance. We don't deal with population variance a whole lot. We'll use it some, but what we'll use even more is the standard deviation. So once you have this answer, you just take this answer and you take the square root of it. And that's going to give you your standard deviation. So that's the steps that you use to find the population variance, population standard deviation. So this is sort of what our chart's going to look like. This column, I would rather you order them. It's going to make it easier on you if you put them in order instead of they just put them in any order in there. I'd order them from lowest at top here down to highest. And then we do x minus the mean, x minus mu. That gives us each of these numbers. You don't really have to show all of your work like they did here. They showed all their work. That's unnecessary. Just write down what you got when you subtracted each one. Then you square each one. Notice when you square a negative 0.5, you end up with a positive number. So then we're going to have all of those answers and they're all going to be squared. And again, you don't really need to show all this right here. This is the part that you care about. It's this out here. Then we're going to, when we get done, we're going to sum all those up. We're going to add them all up. That's the sum that we're going to use. That's what we're going to use for that formula to find variance and standard deviation. So then all we do, we take that sum and we put it in right there on top. There was 10 items in the set, so we put that on bottom, we divide. That's your variance. And it's your population variance, because this time we were dealing with the population. Then once you have that answer, all you're going to do with that is take the square root of 8.9. So grab your calculator and you just take the square root of whatever your variance is, and it's going to give you about 3.0. That's your standard deviation. And what it means for that problem, the population standard deviation is about 3.0, which is about $3,000. And we'll talk about what standard deviation tells us later on. For sample, if we're doing a sample instead of a population, notice here, instead of using sigma, we use an S. And this is for sample variance. So this is the formula for sample variance. The only difference is they use an S here. They use X bar instead of mu, and instead of a big N, they use a little n there, and you subtract n minus 1. So when you're doing a sample, you got to take into consideration that you didn't get everybody in the population, so this is going to mathematically make it a little better for us to have. So we do n minus 1 here. Instead of just, on the population one, it's just capital N on the bottom. And this lowercase n tells us that we're dealing with a sample instead of the uppercase N, which tells us we're dealing with the whole population. Standard deviation sample, notice that standard deviation sample is S. Standard deviation sample is S, and we're going to use that instead of our sigma. The only thing that really changes in the formula is that n minus 1. You still do everything the exact same way. All right, steps for doing a sample, basically the exact same steps. It's just the formula out here is changing a little bit because you got an n instead of a capital N there. You got an X bar instead of a mu there. but we do the same process. So you find the mean, find the deviation of each one, and again, this would all be in that chart. You know, we'd have to make a chart, list out all the numbers that are in your set. Then you're gonna do x minus x bar. Then you're gonna do x minus x bar squared, the sum of the squares. And you're gonna end up with a sum down here. You're gonna take that sum and you're gonna plug it into the formulas for standard deviation and variance. That's what these next two steps are. So notice that the only thing that really changes here, instead of sigma squared there, for variance you got s squared. And instead of just n on bottom, you gotta divide by n minus 1. Instead of sigma there, you got an s there. And again, all you're gonna do is you found this answer. Well, then once you got that answer, you just take the square root of it to get the sample standard deviation. All right, an example here. Starting salaries are for Chicago branches of the corporation. The corporation has several other branches, and you plan to use the starting salaries of the Chicago branches to estimate the starting salaries for the larger population. Find the sample standard deviation and find the sample standard deviation of the starting salaries. And these are all in thousands of dollars. So, all right, this is a list of all of the salaries from the previous slide. And notice they said, change this real quick. Notice they said it's a sample, so we're going to use the stuff to show it's just a sample. First thing we're going to do, we got to find the mean. So that's going to be our x bar. So we're just going to total all these up. You grab your calculator, total them all up. I got a total of 415. There's 10 of them, so we're going to divide by 10. That's going to give us 41.5. That's our x bar. Now what you're going to do with that, you're going to make this chart. And there's going to be extra stuff on this chart at some point. For now, it's just this certain stuff. I'm going to put these in order. I always like to have them in order. Looks like the lowest one's 37. Next lowest is 38. Then we got 39. Then we got 341s. I think we did something with this same list in another class. 42. Then we got 40. Looks like 44. Then 45 and 47. Go down through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure we got them all. Our next step then is to do x minus x bar. So for each one of these, you're going to take this number and you're going to subtract the mean there, the x bar. So if you grab your calculator and you do 37 minus 41.5, and we get negative 4.5. So you write that in there. Then you do 38 minus that, which is going to be negative 3.5. Then you do 39 minus that, which is negative 2.5. Then you do 41 minus that, which is negative 0.5. Negative 0.5 again, negative 0.5 again. Then we're at 42 now. Instead of a negative 0.5, now it's going to be a positive 0.5. Then 44 minus 41.5 gives us positive 2.5. 45 is going to be 3.5. And then 47 minus 41.5 is going to be 5.5. Once we have that, the next thing we do is we do, in our columns here, we do whatever those were, but we square them. So you go down through and you're just gonna square each one of these numbers. So you grab your calculator, and hopefully you'll have some idea so that you don't have to punch all this into the calculator this way. But when you square this negative 4.5, it's gonna come out to be a positive. So just take 4.5 squared, and you get 20.25. 3.5 squared, and you get 12.25. 2.5 squared, and you get 6.25. 0.5 squared, and you get 0.25. 0.5 squared again, you get 0.25. 0.5 squared again, you get 0.25. 0.5 squared, this time it's positive, but that doesn't matter, it's still going to come out to be 0.25. Then the 2.5 squared down here is going to be the same as the 2.5, negative 2.5 squared up there, so it's going to be 6.25. 3.5 is going to be the same as the one up here, 12.25. And then the 5.5, square that, and you get 30.25. Now, what you have to do with all those, and what you're finding when you're doing this, is you're finding that SSX, the sum of all the squares. So we're just gonna add all of that whole column up. So we add up 20.25 plus 12.25 plus 6.25 plus, and you could, what I'll do with those right there, I know 0.25, 0.25, 0.25, 0.25, those four together make one whole, so I'm just gonna put plus 1, plus 6.25 again, plus 12.25, plus 30.25. Make it as easy on yourself as you possibly can. And all those total up to be 88.5. That's your sum of your squares. Now the next thing we do, we want to find the variance, which is the s squared. We go back to the formulas. We go back to these formulas. Right here is the variance formula. It's the sum of all the squares over n minus 1. So you got that sum of all the squares, so all you got to do is put that number on top and then do n minus 1 on bottom. And then to find the standard deviation, we're just going to take the square root of that. So we go back to this slide. So it's the sum, it's this number right here. That's what we put on top, 88.5. And we divide by how many numbers we had. Well, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we divide by 10, we end up with 8.85, or about 8.9. Then all you got to do with that to find the S, which is your standard deviation. Remember, this is your variance. Variance. This is your standard deviation. All we got to do is take the square root of that 8.85. So I just grab my calculator, second square root, 8.85, and I end up with about 2.97, which they told us to round it off to one place farther than what we were. So about 3.0 would be anything in there I probably would accept. this is the book working it out. They found all those. Notice they got 8.8 or 88.5 for their sum of their squares. Next thing they did, they plugged in, they rounded off to 9.8. Oops. Let's go back because I messed up. I messed up right here. This should be 10 minus 1, so that's going to change this. I forgot we were doing a sample. So you do 88.5 divided by 10 minus 1 is 9, and we get 9.83. 9.83, or about 9.8. So I messed that up because I forgot we were doing a sample. Then you do take that 9.8 and you take the square root of that, second square root 9.8, and I get about 3.1. So this is wrong. Our standard deviation is going to be about 3.1 on that. So it makes our standard deviation a little higher because we were doing a sample, because you had to do that 10 minus 1, the n minus 1 in there instead of just the n. So they got 9.8, that's what we got. 3.1 is their standard deviation. What that's telling you is if you're just using that as a sample, then your standard deviation is about 31 or $3,100. What that's sort of telling you is that you expect that your salary should be somewhere within about $3,100 of the mean or the normal. And we'll talk more about what it actually tells you later. All right, I was hoping I'd have a calculator that I could pop up on the screen, but I don't think I do. It's still downloading. If you're on your calculator, if you're on your TI-83 or 84, you hit the stat button. Stat button is right next to the up and down and sideways arrows up towards the top right hand side. Once you hit that stat, it pops up a new screen that says edit, calculate, and test across the top. You just want to hit edit. So here all you're really going to hit is enter. And it's going to pop up a screen that looks like this. And it's got like L1, L2, L3, so on and so on. And what you're going to do is you're going to punch in all your data into one of those columns. So if I go back and I'm going to punch mine into L1, all you would do is you'd go back to the data, and you take all this data here, and you punch all those into the calculator, into that L1 list. So you punch in 35.00, and then just hit your down arrow, and then punch in 23.75, hit your down arrow, so on and so on. And when you get done, make sure there's 3, 6, 7, 8. Looks like there's 24 pieces of data, so make sure you got all 24 in your calculator. Once you have all that punched into your calculator, just push the stat. Once you have it all in that list, push the stat button again. And this time, you want to go over to calculate. So you just hit your right arrow button, and it goes over to calculate, and it pops up a screen that looks like it says number 1, 1 variable, so on and so on. Number 2, 2 variables, and we're going to use this screen a lot, so get familiar with it. It's got all kinds of stuff all the way down through there. And what we want the one variable. So once you go over to calculate, and the number one is highlighted, it's darkened in, all you're gonna do is hit enter. And you hit that. So once you hit one variable, you hit enter. Now you're gonna hit second. And you hit second, and then you go down, and if you put all your numbers in list one, if you put all the numbers in list one, you're gonna go down to the number one on your calculator. So you hit second, and then you go down and you hit the number one, and you'll notice it'll pop up L1. If you put them in list two, then you go down and you hit second, and you go down and you hit number two. If you hit list, or put them in list three, you go down and you hit number three, so on and so on. It's got the L1, L2, L3, all the way up to L6 above the numbers down there on your keypad. Then you hit enter, and what it's gonna do, it's gonna give you a screen that's gonna look, let me erase all this. It's gonna look something like this. It's gonna say one variable stats, and then it's gonna give you this equals, this equals, this equals, this equals, and it's got this equals, and it's got n equals, and you can actually go on down. If you push your down arrow, then it's got min x, q1, MED, Q3, max x. Alright, so it's got this whole list of stuff. Well, a lot of these you should recognize already. This is your mean, so it tells you the mean of the set of data. This is all your data added up, so this is the sum of all the x's. Sum of all the x's. This is x squared. We haven't talked about that yet. We will get to that at some point. This, well, S stands for standard deviation, and that's what it's telling you. So the S standard deviation is what that one's telling you. Standard deviation of a sample. Then it's got sigma x, so this is for a sample. Then it's got sigma x, which is your standard deviation of the population. Notice as we do those, they didn't tell us S squared or sigma squared. They didn't tell us the variance for each one. To find the variance, what you'd have to do is just take your answer, whatever it says right here, and square it, and that would give you the variance. Then your N stands for the number of items in your set. Your min x tells you the lowest number. We go down here, the max x tells you the highest number. Q1 and Q3 are quartiles. We haven't talked about them yet. MED is the median. So that's the number that's right in the middle of the whole set. So you use that screen, if you can punch the data into there, use that screen, it gives you all that information. The only thing it doesn't tell you is it doesn't tell you the variance. And to find the variance, you just take whatever this answer is, or this answer, depending on if you're dealing with a sample or a population, and you'd square it, and that would give you the variance for each one. So you can use your calculator for that. Notice the screens right here that they show. Got your X bar, you got your standard deviation for the sample, how many items were in the set, so on, so on, so on, for all these different things. with standard deviation. Your standard deviation must always be greater than 0. If your S came out, if your standard deviation, your S came out to be 0, then that means every number in your set is the same, because none of them deviate. They all deviate 0 from the mean. Standard deviation is the measure of variation of the values from the mean. So when you're looking at standard deviation, what you're looking at is the larger the standard deviation is, the more the data varies. So the wider the range is. The units of standard deviation for S is always the same as the original units. So in that problem that we were doing, it would be thousands of dollars. The value of the standard deviation can increase dramatically when you throw in outliers. So when you have an outlier, that's going to make the standard deviation get a lot bigger. Key points for standard deviation. All right, interpreting standard deviation. Standard deviation is a measure of how much an entry deviates from the mean. The more the entries are spread out, the greater the standard deviation. We talked about that on the last slide. If S or that is 0, then that means all the data is the same. Standard deviation is always positive. The closer to 0, the closer together the data is grouped. The farther from 0 standard deviation is, then the more spread out the data is grouped. So if we look at this, we see our standard deviation for this one's 0 because our whole set of data was all 5. If we look at this one, our mean here was 5, our X bar was 5, but we notice that it's a little spread out, but it's still pretty close to 5, so the standard deviation is something like 1.2. Then we look here, the mean was still 5, but in here there's nothing, and the data is really spread out, and our standard deviation was a little more, it was 3.0. Alright, these are all the different symbols. Might copy this down. That's all your symbols for variance. If you're dealing with a population or you're dealing with a sample. Symbols for standard deviation, symbols for mean, number of entries, the deviation, and then the sum of squares. And this should be, that right there should be X bar. My bar looks like it got moved a little bit or something. The assignments on page 90, 1 through 8, 11 through 24, 27 on 27. When you read the problem, separate male and female. Hopefully, once you read the problem, that'll sort of explain itself.